Work and energy. Let us understand what is work. See these two students studying. Are they working? You would feel, of course, yes. Study is work. They are studying, hence they are working. But sorry, they are not. Does that confuse you? According to physics, work is said to be done when force is applied on a body and this force causes a displacement in the body. Did the children apply force on any object, causing it to displace? No. So, they were not doing any work. Mathematically, work is equal to force into displacement. We write this as W is equal to Fs. The unit of work is Joule, unit of force is Newton, and that of displacement is meter. So we write 1 Joule is equal to 1 Newton into 1 meter. Let us define 1 Joule. 1 Joule of work is said to be done when 1 Newton of force causes a displacement of 1 meter in an object. So we have two units of work. One is Joule and the other is Newton meter. Note that though force and displacement are vectors, work is a scalar quantity. So, the two things required for work to be done are: first, application of force, and second, displacement. Absence of either or both means work done is zero. Can you tell the work done in this case where a man is pushing a wall? It is zero. Though he is applying force, displacement is zero. Hence, the work done is zero. So what factors does work depend on? First is magnitude or amount of force. Second is magnitude or amount of displacement. And third, angle between direction of force and direction of displacement. More the amount of force, more is the work done. More the amount of displacement, more is the work done. We'll study the third point in detail. Let us see How does angle between direction of force and direction of displacement matter? Case 1. The direction of force and direction of displacement is same. The force was applied in the right. The displacement was also towards right. So the angle between the two is 0. So direction of force and displacement is same. Angle between direction of force and displacement is 0. In such a case, we say that the work done is positive. Let us study how does the angle between direction of force and direction of displacement matter with the help of an example. A person pushing a car. The direction in which he is applying force and the direction in which the vehicle gets displaced is same. Now let us see how does the angle between direction of force and direction of displacement matter in case 2. Here the force is applied in the upward direction and the displacement is in the forward direction. So we get the angle between the direction of force and direction of displacement is 90 degree. In the first case, the direction of force and the direction of displacement was same. In this case, they are mutually perpendicular. So in the case 2, direction of force and displacement is mutually perpendicular. Angle between direction of force and displacement is 90 degree. We say work done is 0. Remember, here the force applied is not causing the displacement. Let us see this case with the help of a real life example, a coolie. A coolie carries luggage over his head and walks in the forward direction. So the direction of force and displacement is mutually perpendicular. Angle between direction of force and displacement is 90 degree. So the work done when a coolie carries luggage over his head is 0. Remember, the force applied is not causing the displacement. Now let us see case 3, how the direction of force and direction of displacement matter. Here, there is a tug of war between a few people and an elephant. The people are applying force towards left, but due to the great force applied by elephant, they are getting displaced towards right. So we see that the direction of force is towards left, but the direction of displacement is towards right. That is, the angle between the two is 180 degree. So we see that direction of force and displacement is mutually opposite. Angle between direction of force and displacement is 180 degree. In such a case, the work done is said to be negative. Here again, the force applied is not causing the displacement. Let us see this case 3 with the help of another example. When a ball is thrown up, the direction of force on it is the same as the direction of gravity, that is towards the center of the earth. The earth is exerting a gravitational force on the ball which is directed towards its center. But the displacement of the ball is in the upward direction. So the direction of force and displacement are mutually opposite. And the work done in this case would be negative. So direction of force and displacement is mutually opposite. Angle between direction of force and displacement is 180 degree. Hence, the work done is negative. Again, here the force applied is not causing the displacement. Let us revise. Work is said to be done when force is applied on a body and this force causes a displacement in the body. So work is equal to force into displacement, or W is equal to Fs. Unit of work is Joule or Newton meter. We say 1 Joule of work is done when a force of 1 Newton causes a displacement of 1 meter. Amount of work done depends upon the force applied, the displacement caused, and the angle between the direction of force and displacement. Work can be positive, 0, or negative. Work is positive when the direction of force and displacement is same. Work is 0 when direction of force and displacement are mutually perpendicular. It is negative when the direction of force and displacement are opposite to each other. So we get that the angle between the direction of force and direction of displacement in case of positive work is 0 degree, in case of 0 work is 90 degree, and in case of negative work is 180 degree. Positive work causes acceleration in the body, while negative work causes retardation in the body. 0 work causes neither acceleration nor retardation. The real life examples of positive work is pushing a car, while that of 0 work is coolie carrying a luggage over his head and walking, whereas the example of negative work is the force applied by gravity. Thank you.